And let's start. Face-to-face and online, both recorded, as I said. And you have, I am just checking out. Okay. There is some things I wanted to point out. I'm sorry, in our webpage for the conference, Samantha, who is a co-organizer, she's sharing things. One of the things is how to get to Wi-Fi at FAU. If you want, this is on our webpage. It explains this guest Wi-Fi for FAU. You have to give your phone number, and it's you can access. And also we are giving Wi-Fi. We can do that twice. Without further ado, our guests are speaking. Welcome.
Thank you, Tasha. Okay, good morning, everyone. Good morning, people online, from everywhere around the world. Good morning, participants in person. So, yeah, you can hear it probably from my accent. We are, and also Melanie, if you say something, then probably also.
Hello, will be already enough.
Yeah, so we are from Austria. We are part of the GeoGebra team. And yeah, Markus sent us here to show you a little bit about the present of GeoGebra and about the future of GeoGebra. We just want to give an overview of that. And in the afternoon, for the participants in person, we will have a workshop where we get into more details of this. Yeah, probably something about us.
Yeah, my name is, in short, Melly. That's way easier. I'm part of the GeoGebra team more than 10 years already. My background is math education and computer science. So officially, I started as a software developer at GeoGebra. So the tools that we are using today in our afternoon workshop, I was also helping to implement those applications. And yeah, currently I'm the so-called product owner of the GeoGebra apps, so the math calculators. And
yeah, my name is Tanja. I'm with GeoGebra for 5 years now. I have a background in mathematics education and chemistry education. And after teaching for a while, I went back to the university and to GeoGebra. And I'm now the lead of the website team. So probably some of you are familiar already with GeoGebra Classroom and the materials and all of these kind of things. So these are part of my responsibilities. Before we go, so we jump into the present, and I have here a nice picture of the GeoGebra team. So last September, we went on a team gathering. So you need to know, we are around, I don't know, 40 people. And these people are spread over the world. So we have colleagues in UK, US, of course, Austria, Romania, Hungary, Italy, India. Did you forget anything? No, but yeah, so we're quite an international team, and there we spend some real nice time together. Good. So I will hand over to Melly now for the first part of the present.
Yeah. So thank you, Tanja. We will first start with an overview of the GeoGebra calculator apps that can be used in your classroom. And first of all, I also wanted to know from you, so who has already used GeoGebra in their classroom? Okay, here we have almost half have already used it. And the others, do you know GeoGebra already? Or is it something completely new for you? Quite new, okay. Then I like to start just also with a background so that you also know a little bit of the history of GeoGebra. And as Markus also mentioned today already during his short presentation, the basic idea of GeoGebra is also that it combines geometry and algebra. Should I wait? Okay. So the basic idea was a combination of geometry and algebra. So in this screenshot, you can see the original desktop application of GeoGebra. So first it was implemented as a desktop application. And the idea is that you have for students the algebraic representation of objects and also the geometry representation. And both views are connected dynamically. So which means if I move a point around on the graphics view, I can also directly see the algebraic representation, how it changed. So this was the basic idea, and it was just for desktop applications. And yeah, so the users, they grew, and next to the technology, there were also changes. So our users, they also said, yeah, well, sometimes I just want to use GeoGebra in a browser. I don't want to have an install application. So they also requested a web version. So a few years later, we also started to implement a web version of GeoGebra. And here you can also see a really old screenshot. And after the web technology changes, there came further changes to the technology. So suddenly the students were using tablets and smartphones in their classroom. So we also had to act on this. And in 2012, we also started with the first tablet version of GeoGebra. And as you can see, we have already tried to modify the application a little bit because we thought, okay, the handling on a tablet with your fingers is a little bit different. So we have implemented the same power of GeoGebra, but with a different user interface. And also for smartphones. So for smartphones, we had the problem, okay, we have just a small screen and we somehow have to adapt the user interface to pack everything into a smartphone version. So as you can see, we have a lot of technology changes. But in addition to the technology changes, the users also requested more features. So next to geometry and algebra, our users said, okay, but what about 3D? I also want to have the power of 3D in GeoGebra. So it was also included, and similar to spreadsheet or statistics. So GeoGebra just grew. And also in the screenshots, you can see there's a lot of power. So you have a CAS view, the spreadsheet view, you have a lot of tools. And at some point, we also thought, okay, for us, it's important that students can easily use it. It should be intuitive. And with this interface that you may still know under GeoGebra Classic, for the ones that already know GeoGebra, it might be a little bit overwhelming, especially if you think of young students, then it should be really easy for them to get started. And this was the reason why we then also decided that we are starting new apps. So where did I click? So we started to split up the applications really for the context that the student needs. So now we have a separate calculator for scientific. So in scientific, it's really just like a simple handheld calculator. You can have simple calculations. We do not support any graphing. It's really just limited to what the student needs. And we did the same to a couple of other apps, like geometry for geometric constructions, a graphing calculator, a 3D calculator, and also a CAS calculator. And especially the last one is used more for Europe, because in Europe, also the school system is a little bit different. There we have a so-called application calculator suite, and there we again pack all the power into it, but that has also some mathematics system background. I don't want to go into details of all the apps now, so you will also get to know some of the applications later in our workshop. No, not done. Too early. So now you have seen the calculator applications. In addition to that, we have also a pretty cool application that called GeoGebra Notes. And this is actually like an interactive whiteboard. So if you imagine if you're standing in front of your classroom and you also have maybe a smart board or something like this, you can just pop it up on your screen and you can directly write on it. So we have a pen function. Here in this example, you can also see you can add text and you can also include an GeoGebra application. So in case that you want to graph something like here, you just put in a GeoGebra element, and then you can also use your pen and just note important things like here, the slope or the linear functions. And something really exciting for students and also engaging for them is a feature in our 3D application. So who has already experience with augmented reality? Okay, so I hope you are also as excited as I am. So I've recorded a short video for you. And if you start the 3D application, we have a feature so that you can switch to an augmented reality view. So here, when you start the application, you can see on the top the 3D view, and at the bottom you have an algebra view. So here you have seen it with Steve verbs already. Here you can input specific equations, for example, and I just enter an equation, x to the power of 2 plus y to the power of 2. Now you have it in a 3D view. But the augmented reality view has a great potential, especially for the students. So I just continue. So now on the bottom right corner, you can see a button called AR. So if you click that, you can just switch to the augmented reality view. What's happening now is, now you can see the screen, so the camera view. Now I'm looking for a plane where I can put this object on. So I scan around and then I just tap on a screen to place the object. And now you can see I can really walk around the object. I can look at
hotel.
Yeah. So you can walk around it, you can look at it from the front, you can even walk into, that's so cool. And now you can see if you look at it from above, the cross section from above results in a circle. So this is something your students could just discover. Yeah, I just let it play. So I've already created this paraboloid. I could also just open it again and just change the equation. So that's what I'm doing here. And your students could do the same. Again, they can walk around it, just see how the paraboloid has changed. And also the cross section again. So we really think that AR has also great potential for math education, because we know from math education research that many students have problems in connecting a picture on a 2D screen with a 3D object. And still, if they can rotate it on the screen, in fact, we still give them just a 2D image. And with AR, it's really cool because they can really put the object into their known environment. And then they can just walk around and also explore it. So, Tanja, now I'm really. Yeah. So I'm done with the calculators. Now, a feature that I just wanted to mention is this exam mode. So in all our apps, we have in the menu an entry that's called exam mode. And if you are using GeoGebra during your classroom, when the students need a handheld calculator or a graphing calculator, students can just manually start the exam mode. So what does the exam mode mean? The students have to turn on all the connections. So Wi-Fi, Bluetooth needs to be turned on so that you cannot cheat and get messages from other students. And the whole mobile device is locked to GeoGebra, so they cannot leave the application. And during the exam mode, you can also see the special color. So as a teacher, you can easily see if the application is running in exam mode or not. And yeah, we have also included a timer. So if I know, okay, at 8 o'clock we started the exam, then you can also check the timer if everything was okay and the exam mode was running okay. And in addition to the student-initiated exam mode, we have also a version for device management systems. So if you're using, for example, GEM, this is an example from the New York district. Rob was there, so he also was included into this exam mode trial that we have started already many years ago. And in this version, you really have the administrator who says, okay, all the students, they are now in the exam, so I start for them the exam mode. So then the tablet is really locked for all the students to GeoGebra. So, and now I'm really done and I can hand over to Tanja.
Okay, so need to go to the microphone so that everybody hears me. So wasn't it really nice and cool what Melly just showed? So all of this is in hands of Melly. Okay, and now we're switching over to the other part of GeoGebra, to the part of the resources. So on the GeoGebra website, so probably you are familiar with this page. So we have the apps, and as develops or many others, users are creating applications and applets, and they're saving it in their profile. But not only are they saving it in their profile, but they're also publishing it and sharing it with the community. Okay, now it got loaded. So they are also sharing it with the community, and we display them on the website. So you can, for example, look for something for functions. We have a topic graph on the resources page, and then you can look for all different kinds of materials. You can open them and directly use them for your class. So there's no need to create everything on your own, but we also have the possibility to use, adapt, share one of these over 1.5 million open educational resources. So that's on the website. And so now we have these resources. I hand them out to my students, or I want to give them to my students. And I want to see what my students are doing. So we have a great tool for that. And I'm really proud of this one, GeoGebra Classroom. So it's for live lessons where you hand out digital GeoGebra resources. For example, let me look up something. I'm not signed in. Okay. So something with linear functions, for example. So you can also use the search for searching for a material. Linear function. Okay, make a linear function. Looks good for me. So I want to use this material from John Albright, and I want to hand it out to my students now. So we have this assign button on the upper right corner. And if you click this, then you can choose between two options. Either you just share it on the GeoGebra platform within GeoGebra Classroom, or you can also assign it in Google Classroom. Does anybody use Google Classroom in here? So this is really powerful for you then. We will see that also today in the workshop. We will try that out together and see how this is working. But just for the demo now, so as a teacher, important thing, you need to have an account. You need to be signed in because we need to save it somewhere. So everybody who doesn't have an account, create one. So you get a lot of benefits there. But I will not do that now. So I will just show you the screenshots. What you get then is a teacher dashboard where you see what your students are doing in real time. It gets saved automatically. You have several different tools for facilitating class discussions. You can pause the lesson. You can hide and show names. Yeah, and you can not only use it in live lessons in the real classroom, you can also use it for homework. So we will also look at these different scenarios today in the workshop. And as mentioned, you can also assign the resources to Google Classroom. Not only assign it, you can also save it as a draft. So I'm not sure if someone uses this option, but to edit it later on, and also you can assign it not only to one class, also to multiple classes. So yeah, there are a lot of possibilities there. And the big advantage of it is students don't need an account. So students just use their Google Classroom account. That's it. And they can access it. That was the present of my universe. And I will jump into the future of my world, of my GeoGebra world. So I just said we have over 1.5 million resources available from the community for the community. That's quite a lot. So how do I find now a resource that fits my curriculum, that fits my lesson, that has a certain styling, or just, so the resources are basically all great, but sometimes I would like another question in it, or I would like it, to look nicer. And we have started in the last year a big project for practice resources, or generally resources, where we want to provide something to the teachers that they can directly use in school. So there's no need to create anything in the applications themselves, but we did that already. And you can then use the full power of GeoGebra already done, and with some questions aside. So I will show you that in a minute. But we also did some other things before that. So we're currently also working on a solver, which gives step-by-step explanations. And so basically you can enter any math problem, but that's not the way we want to have it. We want to develop it further. We want to get this into a practice system. So in the background, we have a step-by-step explanations, and the end product should be a practice system together with graspable math. So GeoGebra and graspable math will join forces and will create a practice system where a student can say, or a teacher can say, I want my students to solve a specific problem, but they can't be at every student's desk at the same time and can help them. So I hand out such an example in the practice system with the students can use the graspable math interface. So there will also be a workshop by Tim afterwards where he shows graspable math for those who are not familiar with it. And while the students are trying to solve this mathematical problem, they are prompted with, for example, feedback. Is this step correct? So the solver knows that, so the GeoGebra engine. We can also get text hints, like you saw here at the show hint example, and feedback. We can also display the best next step, so the goal state, for example. So there are a lot of possibilities there. We're in the beginning phase of it, but we are very excited to have probably a first version already this year for you to try out. And yeah, so that's really a great new project. And so that's one type of resources we would like to provide. The other type of resources are with GeoGebra applications. So we have started a content project where, for example, Samantha is also part of that project, where they are creating, based on instructional designs from US teachers, resources for exploration and for practice, where students learn specific skills. One example I want to show you here for identify, for example, for the skill identify an angle. I really like this because we not only can use the power of GeoGebra, but also we have nice illustrations in there. So we have this magnifying spyglass, and we can move it around and see, oh, there's a right angle inside. So I can move it around, explore different angle types inside of this picture. But that's not the only thing I can do. I can get a new picture. I can check these objects for angles. And this resource could then help to show students different types of angles and help them to identify them. So the important thing is these resources can help you in your classrooms. We are currently focusing on grades 4 to 8, and we will then continue also to the higher classes. And not only are we working on this, but then we have these resources and we want to provide it for you in a good way. So we're also redesigning the resources pages on the GeoGebra website so that you can say, okay, I'm in this grade level. I look for resources for a specific topic or for a specific skill. And then you're prompted with those. And you can easily assign it, for example, in Google Classroom. So this is something that we want. So the first bunch of resources and teacher website is something we want to have ready for the next school year. So stay tuned for that. And if you are interested in this project, so what's ongoing there, if you want to see some more resources, we will also see some more in the afternoon today. But if you want to do that, for example, during lunch, have some casual talk. So Rob will have some kind of a table set up. Do you want to say anything about that?
At lunch, while you're eating, basically, I'll have a bunch of papers out with QR codes in them. You'll be able to click on the QR code and play with some of these resources. And there's also a link on that piece of paper where you can give your opinion and your review and your suggestions about each of the resources. So be very casual, just while you're reading it. Actually, tell me where to put a table, and we'll have those papers out and play around.
Exactly. So Rob is there to try it out. And also today in the afternoon, we will have the possibility. Good. Then I will hand over to the future also of Melanie.
And so one feature that we are currently working on and that we are really proud that we can also show you today is an enhancement for our GeoGebra Notes application that I just showed you previously. And because we are working on a tool so that students can directly collaborate within the application. So the first app that we are working on is GeoGebra Notes. So the plan is that you can really open GeoGebra Notes, and as a teacher, you can then share the link with your students, for example, and they can really work together on the same file in real time. The future plan is also that we include it in the other apps, but as a first step, it's Notes, and we can also quickly demo it for you. So I have my assistant, Rob, and Tanja. So this is our working environment. Let's change the name maybe to my real one. Join. So it's still O, there are already objects. And let's see, I can see Tanja is in, Rob is in, and I can see really live what they are doing. Okay, maybe let's join their drawing. And you can also see the color. So the students will also see, okay, which of my colleagues is currently writing hi here, or who is creating what, so that they really always know, okay, who is in my group, who are my co-workers. Yeah, so this was a short outlook what we are currently working on, and we are really happy if we can release it, and I hope that you will also enjoy it. No, it's still secret. So.
But in the workshop, we will find out.
Like whiteboard, but with GeoGebra Patcher.
Yeah, we haven't inserted any objects like this. Good, right? There you go.
So you could also now already include a GeoGebra element.
So it's interesting because, you know, this first, of course, became hot and heavy of interest during COVID when teachers were teaching remotely, acting one is with. But now what we found also is that also a great interest for collaborative learning and collaborative work. We've been visiting schools this week, and we noticed many of the schools have kids sitting in groups and tables and
Yep.
stuff. And this would be a way for them to work together collaboratively on a single document.
Yeah, so we have also reserved a few minutes for questions and answers. But before we go into this QA session, Tanja also wants to just mention one last information for you.
Yeah, so also I want to advertise again the community program, community involvement program. If you stay up to date, if you want to stay up to date, join, and we will give you the newest information and newest functionalities directly after a release. And the other information, so we are going to share this presentation with you. If you would like to get a copy of it, please scan this QR code. You just have to fill in then your email address, and we will send you a link to this presentation. Then you can also get the screenshots. You can have some links to discover. And yeah. Thank you. Yeah.
Finish your presentation for today, and then question and answer. My question is, what is accessible right now from what you said? And most things are not accessible, but we can have a use of it during your workshop. Yes, that will be like multi-tool. I wanted to point out that one of the things, I don't know if you realize, if you create the GeoGebra resources, usually there's one author. Yes, there's one author, and to collaborate, it was up till now, it was very difficult. You created something and then you can share with other people, but if somebody else changing, this is not like you are working together. So this tool, which is like collaborative tool, it's really something which, as you said, especially after teaching online, and it's wonderful for group work, students work, teachers work. So I'm really looking forward. Is there any question from the, yes?
Yes.
So there is some future they didn't talk about. I don't know how much you know, GeoGebra. There's something which is called nodes. And the nodes is a tool, yes, to create all kinds of rich environment. So as I understand, the collaborative is in the nodes, yes?
Mm-hmm. Yes.
So this is you can put all kinds of pictures, videos in the nodes.
Yeah,
Yeah.
so there's, for example,
And this
So-
is accessible right now, okay, just for single use.
so this is GeoGebra Notes, and at the bottom you have, we call it the tools panel. So here you have a pen tool, You have the highlighter if you want to highlight something. We also have shapes. So in case you just want to draw quickly a shape, you can just use those. And in the last one, it's called Media tab. There we have a lot of different tools. So for example, a text tool. So you can really just write text. You can format it. You can change the style. You can really do a lot with this text tool. You can also add a table. So maybe you want to have a math table here. So you could just add data. You can also add rows, add columns, do automatic styling. If you add data points, you could also use different charts. So your data points are directly created into a chart. For math especially, you can also use the equation tool. So if you teach something about equations, then you can also use the special character so that you can also display it nicely for your students. Then, of course, GeoGebra. So you can embed GeoGebra and also use the same tools that you already know from GeoGebra. For web, we also support, if you have, for example, a YouTube link, we would also recognize it as a YouTube link and just display the video. So you can just, put any web link and we just display it.
Can we add something on there, on the web? So, so that would also then come in handy with the US content project, because we also recognize if, where is that? If we have, I'm just looking for the resource. It is. So, so that's this link. So if I would grab a link of a GeoGebra resource, then, oops, I'm not used to Windows.
I think that's
Little copy, and I go back to notes, and I would insert this link. Then it also just extracts the applet itself, so the GeoGebra element, and I can then rescale it and also directly interact with it inside notes. And beside, students could write down the observations, could write down what they saw.
So if I also can understand your question more, because my teaching experience, not only can you pull in PDFs, what I have seen classroom teachers do is this: they pull in a GeoGebra graphing calculator, they put a PDF on as a backdrop. They maybe the video or PDF has got an illustration of some kind of parabolic function. It's plot points all in the function. They find the line of best fit, and they can find the equation of the basketball as it is shot right in the image of the video or the PDF, that type of thing. And one thing I want to make sure to make it clear is that the same thing is true with all GeoGebra. When you bring in any of these elements, graspable math or equations and stuff like that, it is almost none of it is an image of that stuff. It is the working, functioning piece of that. So if you type in an equation, that equation can be graphed, right? And just pull it, you can connect it to the graph. You can, everything is, so what Tanya's doing now is, putting in some kind of expression, and it is all operational and functional and not just like a text box, right? That's the idea. Text boxes are nice to make your point, but if you want the student to learn with it, it's got to be functional, and they pretty much all are.
And maybe you point out at last conference, we have a beautiful presentation, but Ed Knott, who is a teacher in Broward County, and he was showing how he's using notes in his work at school. The link for his presentation is in the GeoGebra YouTube channel from last year. Ed Knott, he was having a presentation.
K-N-O-T.
I think that we will put in our webpage for the conference the link for this year recordings and previous year's recordings. So one of the things is good to see how real teacher is doing this in the classroom. So he has our workshop. It was an online workshop recorded, how he used notes in his real class, not only the possibilities, but real examples. Okay, no more
Any other
questions? For the creators and of the software and improvements of the software and the sources. Yes, this is amazing that. Okay, if not, then thanks you once more.
Thank you.
And our next section will be there's some question.
Online question.
We have, you know what, Samantha's asking a question. Okay.
If you're the user of the college, you're
Oh,
the
it's-
that is dumbing down education. I think that's a fair question. I think that's. a
Maybe
fair
I can answer this question.
Yeah, I was
We
gonna
have
say.
here at FAU, we have a professor, he's right now unfortunately retired, Paul Yu. He's a professor of geometry, and he has a research paper, Geometricum. It's a worldwide research paper with peer review, and he was using GeoGebra. They are using GeoGebra for not only illustration of the problems, but also of setting up the problems, besides setting maybe in a formal language, setting it in geometric language. And it's very interesting if you look, if you have a background, if you have like a perspective, like some other people have maybe. When I started studying mathematics in Poland in 1980, there was no computer. Yes, there was no computer. We have to set up all the problems. There were computers, but not accessible, not personal computers. And you see the huge improvement of the science because of the computer, because of the visualization, because of the challenges. So GeoGebra is just a tool. And the question is, who is using that? Yes, you can use it to like simplify things for kids, visualize, but you can also do high math. Just Google or search in GeoGebra topology. And there are questions or there are setups which, to understand how to create it, how to use it, they create a really deep mathematical knowledge. And I would say that there's a huge shift in mathematical sciences, huge shift including computer science, visualization, not speaking about, you know, fractals and chaos, which had a huge impact. It started with visualization and had a huge impact on all science, not only mathematics, but physics, chemistry. So, you know, computers, they are just computers. They are as smart as we are, yes, as a user. So you can make use of computer to very oversimplify, but you can also challenge. So I think it's a question of who is using and how it's using. I think if I may, I'm very passionate about the computer and has a perspective.
And I don't think I could have said that better. Right? I wanted to do this with Sam. Sam, I know you're trying to satisfy our at-home viewers while we're satisfying our in-person viewers. So Sam, here's, in other words, here's what I would type to an at-home person. I would type that GeoGebra is a tool made for teachers. What the teacher does with it is she's the only person that has the power to decide if it dumbs down the teaching or if it enhances it. GeoGebra, the teacher is the only one who can make that decision. I would argue that Steve Phelps, for me, did not dumb down statistics. Steve Phelps did an experiment that I never could have done, where he did a simulation 205 times. And I realized that a bell curve is being created and the edged outliers rarely occur, right? So, and that happened not because it was good. That happened because of the way Steve Phelps presented. Okay? So GeoGebra is a tool that the teacher can use. How they use that tool and whether they enhance with it or dumb down with it, that's up to them. So they don't want to have, you know, no matter what. We had this conversation yesterday. So funny because we were saying, you know what, we make these tools for teachers. Yep, I'm sorry. Oh, we make these tools for teachers, you know, but the bottom line is, you know, it's almost like those people who are afraid that computers were going to replace teachers.
I don't know about all of you, but there's anything that I got out of COVID is that nothing will replace a teacher in a classroom, right? I mean, it was obvious that was the most, important part is the teacher in the classroom. So, that would be my answer to the person at home, that they're the only ones that have the power to decide what to do with you. No, right? Yeah. Use George Offman. This afternoon, what my colleagues are going to try to do is, again, we talked about this personally, some of us and in the audience, they really want to try in those workshops to let you experience how to change how you teach using this tool so that you can use it to really make your students experience the math and learn it from the math. That's part of, it's funny because a presentation is one thing and a workshop is a whole nother experience, which is why next year we want our at-home viewers, if possible, to come to the beautiful FAU, all right, and come down here and experience the workshops in person.
Okay, thank you very much. And I think it's an open discussion in mathematics community also. There is still place for the paper and pencil, and but there's more and more. We see more and more research using computers, and GeoGebra is just a tool, but it's incredible tool. It's worth checking, also for personal development as a mathematician. Okay, thank you very much, girls. So now we will have a short recess and we will stop microphones, and in next section will be Tim Brzezinski. Tim Brzezinski, it's Brzezinski's Polish name, and I should know better. I should know better. Winkowska Nowa, give me a break. Of course, it's this Americanized version. But Tim will be talking about using graspable math to support algebra fluency and make conceptual connections. He's incredible creator, he's an incredible teacher, and we are very happy to have him. He will start in 10 minutes. Okay, short recess. Thank you.